Hello, in this video we're going to finish up chapter 4.3 in the Lock 5 textbook. So I want to go through a complete hypothesis test. I write this in kind of 5 steps. We're going to state the hypotheses, including defining all the parameters, state the observed sample statistic, find the p-value. We're going to use stat key to do that. Make a generic decision about the null hypothesis, to reject or not to reject. And then finally make a conclusion in context, indicating whether or not I have convincing evidence for the alternative, and referring back to the question of interest. So this last step, step 5, this is, I like to think about it as writing a conclusion that anyone could read. You don't actually have to have taken a statistics class to read this conclusion in context. So we're going to look at hormone replacement therapy. So until 2002, hormone replacement therapy, which involved estrogen and progesterone, was commonly prescribed to post-menopausal women. But this changed in 2002 when the results of a large clinical trial was published. So about 16 years ago. We're going to go through this trial and see why they made the decision they did. So in this trial, and there's a group, 2 different groups, 8,506 women were randomized to take the hormone replacement therapy, and then 8,102 were randomized to placebo. This was the control group. And 166 of the hormone replacement therapy group eventually developed invasive breast cancer, and 124 of the control group eventually developed breast cancer. So we want to test to see, is there a difference between these 2 groups? Or in general, the big question is, does hormone replacement therapy actually increase the risk of breast cancer? Okay, so I want to write down the hypothesis. I want to go back a second and notice these are proportions. We're looking at proportions of women that took the human hormone replacement therapy that eventually developed breast cancer versus a control group. So this is a situation with 2 proportions. So I'm going to let P1 be the proportion of women taking hormone replacement therapy who get invasive breast cancer. So this is a population proportion. We're really talking about all women. And P2 would be the portion of really all women not taking HRT who get breast cancer. For the null, we're always going to assume equality. Assuming those 2 proportions are equal, there's no difference in the proportion of women who get breast cancer, whether they take HRT or not. But the evidence seems to point out that actually taking the hormone replacement therapy seems to increase the risk of getting breast cancer. So P1 is greater than P2. All right, calculate the sample statistic. So we've got the null hypothesis rewritten up here. The HRT group is 166 of 8,506 developed breast cancer, and the placebo or control group, 124 out of 8,102 developed breast cancer. So if I want to write down the sample statistic, it's p hat 1 minus p hat 2, which are these 2 proportions. Subtraction gives me 0.0042. All right, so this right here is the sample statistic, 0.0042. So this is, I would argue, in a vacuum, this is a very small change, less than 1% change between the 2 groups, but these are very large sample sizes, so that could still lead to statistically significant results. So to find the p-value, I'm going to show you a snapshot of stat key. We've got a 0.0042, that's always going to be on the bottom, on the horizontal x-axis will be your statistic, and p-value is 0.019. So I want to go through 0.0019 and look at how to actually get this value. So I'm going to look at test for difference in proportions. Look at stat key, we're looking at bootstrap confidence intervals. This was chapter 3. And in chapter 4, we're doing hypothesis testing. This example is 2 proportions. Our first thing I'm going to do is edit the data for the 2 proportions. I have group 1, that was 166 out of 8,506. And group 2 was 124 out of 8,102. Click OK. So right here on the right-hand side, we give us the original sample, the two different groups, the two proportions that got breast cancer, and the difference, 0.0042. I'm going to generate, let's say I'm going to generate 2,000 samples. So we have a sampling distribution. And we want to know what is the probability of getting data like this or more extreme. I'm going to click on right tail. This is a right tail test because we're only looking at this positive side. And I want to change this number down here to 0.0042. And click OK. And notice I got a different distribution. So I got 0.017. Going back into the distribution a while ago. And got 0.019. So at least in chapter 3, p-value is not going to be the same for everyone, even with the exact same data. We would get a p-value of 0.019. So we got null hypothesis, sample statistic, p-value, and we're going to use alpha significance level 0.05. Remember, if the p-value is low, the null must go. Since 1.9% is less than 5%, we're going to reject the null hypothesis. Go back. So that's making the generic conclusion. We're just checking to see is p-value less than significance alpha. Then we reject. And I think maybe the harder part, and I would argue more important, is what's the conclusion of this? So we have convincing evidence that taking hormone replacement therapy does increase the risk of breast cancer. The proportion does appear to be higher. Even though this was a small change of proportions, because the sample sizes were so big, it's highly unlikely. This p-value of less than 2% says there's about a 2% chance of getting results like this if these proportions are equal. So it's highly unlikely these two proportions are equal, hence the convincing evidence. All right, so I'm going to go through this one a little bit quicker. So we've got 8,500 women randomized to take HRT. So same two groups, but now we're looking at any type of cancer. So not just breast cancer. So we have larger numbers, 502 and 458. So if you want to go through this hypothesis, those 5 steps, pause the video and write down your 5 steps. I'm going to go through this a little bit quicker. So P1, the proportion of women taking HRT who get cancer. P2 is the proportion of women taking placebo who get some type of cancer. Always assume equality for the null. And we have a higher proportion that got cancer that take the HRT. The difference in two means is 0.0025. It doesn't seem like a very big difference from the previous example, but the last one was 0.0042. So in this case, if we were to go to stat key, enter in this data, and make sure to change this bottom entry to 0.0025, you should get around 25%. Somewhere between 21% and 28% is reasonable. There will be a range of values, but around 25.25 for the p-value. So we do not reject because 25% is bigger than 5%. With this evidence, we do not have enough to show that HRT increases risk of cancer in general. There is a higher rate, but it's in some sense not higher enough to say that the HRT could be causing it. All right, so as a quick summary, results are statistically significant if p-value is less than the given significance level. And if that's not stated, we assume that significance level is 0.05. In making formal decisions, reject the null hypothesis if p-value is less than significance. Otherwise, do not reject. Don't forget, do not reject H0 is not the same as accepting. We cannot show that the null hypothesis is true with these hypothesis tests. And hypothesis test conclusions include a generic decision about H0, reject or not reject, and a conclusion in context about the alternative hypothesis. All right, thank you.